We are going to study the mean and the variance of a binomial distribution. And earlier in the previous videos, we derived the formula for the probability, binomial distribution probabilities. So we learned that we know everything, every probability, if we know two parameters. So two parameters determine the full probabilities, and basically the mean and the variance is calculated from those probabilities, right? Remember, the mean is probability weighted outcome, and the variance is the mean of square deviations. So basically those two, in calculating the mean and the variance, those probabilities are important, and those probability in turn depend on the parameters. So in the end, the mean and the variance also depend on those two parameters. Those two parameters determine the mean and the variance through the probabilities. The derivation is tedious, so I'm not going to derive. I'm not going to show what is the probability weighted outcomes, what is the square deviations. I'll skip that, mainly because the result is pretty simple. So the mean of a binomial distribution is n times p, so multiplication of two parameters. This is very intuitive. Think about this. You try n times and you get success with p probability. So then, out of n times, how many success do you expect? So if you throw 100 coins, I would expect 50 heads and 50 tails. How did you get that? You are doing it 100 times, multiplied by 50%, 0.5. That's how you obtain the expected numbers. So it's NP. So as n increases, you are going to try more, so you will get more. You are more likely to see more success. And as the probability of success increases, of course, you expect more success, even if the number of trial is the same. So this part is pretty simple. And variance, for the variance, what you get is n times p times 1 minus p, right? It's also pretty simple. So probability of success times probability of failure times the number of experiments. So then the number of experiment is multiplied as, remember, the variance is a measure of variability, and the number and the parameter n determines the range, and the range is another measure of variability. So the wider the range is, the more variable the random variable is, the more variation the distribution has. So it's proportional to the range. And the reason why we have p times 1 minus p is explained earlier. It is maximized, the variance is maximized at 0.5, because this is the point where you cannot predict anything. But as the probability approaches to 0 or 100%, you can predict better, so the variability, uncertainty decreases. That was our intuition behind this formula. You just need to memorize, remember these two expected value and the variance. Pretty easy. And then here is an example. So think about this. So suppose that y is your assignment grade. So maybe when you watch this video, you know your homework 1 grade. So say y is your assignment grade if you randomize your answers. Suppose that you randomize all your answers in homework 1 and y is the realization of the grade. And then there are 10 questions, and for each question the probability of a correct answer is 1 out of 5 choices. Only 1 out of 5 is correct, so 20%. In this case, what is the mean and the variance of your assignment grade? Simple. Use the formula I gave you here. Utilize these two and try to answer this question. Simple. I will show you the answer in 3, 2, 1. The answer is A. Simple. If you multiply these two, you get the mean. And if you multiply 10 times 0.2 times 0.8, which is the probability of wrong answers, 0.8 should be multiplied, then you get the variance, right? So as you can see, if you know the parameters, you can calculate anything. It's simple, like probabilities can be calculated, mean and variance can be calculated. Pretty easy. So I'll give you another example. So now think about, again, it's about reservation. So airline companies accept more reservations than their actual capacity, right? Because they expect there would be some cancellations. So they, like say in this example, I will consider simply there is an airplane which has 20 seats. So in principle, the airline company cannot accept more than 20 reservations, but actually in practice they do accept 22 reservations, say, for example. So they accepted 22 reservations because they expect 2 or more reservations will be cancelled. So in the end, there will be no problem operating this flight. That's their business plan. And I'm going to assume the probability of cancellation is 10% and they are independent. So in this case, the airline company is interested in the number of reservations that are not cancelled, which means this is the ticket holders who actually want to take the flight, right? So, right, the company is concerned about the actual passengers or ticket holders who want to take that flight. We are looking at the distribution of this guy, this definition, and then I believe you understand what's going on, and y is a binomial distribution. It is obvious. Same structure as the example I used before, and then try to find the parameters. It's tricky. So you know that if you know the parameters, 2 parameters, you know everything. So it should be the most important question you have to answer. Find the parameters. It's not there may be not enough information, so think about choose your answer. I will turn the page in 3, 2, 1. The answer is 22 and 0.9. So 22. So you may be confused what 20 or 22. N would be 20 or 22, and P would be 0.1 or 0.9. Let me put it this way. We are in this example, in our previous example, the random variable y was the number of cancellations. We counted cancellations, but now in this example we are counting non-cancelled reservations. We are counting how many passengers come in, right? So we are counting different sides, right? And by construction, we define success. So the event that's counted is the success. So when we like this, when we count non-cancelled reservations, this is success, right? Right? Because the binomial random variable is defined as the number of successes. So by construction, success equals non-cancelled reservations. So then, and remember, P is defined as the probability of success, and I said success is non-cancellation, so P is probability of non-cancellation. You get it? So simply speaking, you have to realize what is counted, what you count. In here, you are counting non-cancellations, and P is probability of that, right? It is 90%. So 90% is the probability that ticket holder does not cancel and show up in at the airport, right? So P is 0.9, and the other parameter N is easier because you can think about the maximum. N equals the maximum possible value. In this case, the maximum possible value of Y is 22. If nobody cancels their reservations, then at the airport there would be 22 passengers, right? So N equals 22, right? So this is how we how we not get confused. So this is the so you may it is pretty important question, and if you understand the structure, it is very straightforward to answer, like what to find what is the parameters. But if you do not have the correct understanding of the structure of this model, then it's super confusing. So this is why I'm making this question. And later, in the next video, I'm going to derive the probability that this overbooking causes a trouble to the airline company. So that is, I will calculate the probability that less than 2 reservations are canceled. So that takes a few more steps. So I'll see you in the next video. Bye bye.